is a hard problem. Is count number of balanced permutation. Uh, you're given a string num. Yeah, so string of digits is called balanced if the sum of the digits at even in this is equal to the sum of the digits at odd in this. So the problem said that we need to return a number of distinct permutations of num. That's a balance, and in the modulo, this is modulo. Permutation is the rearrangement of the odd character of the string. Okay, for example, 1, 1, 2, 3. We have two permutations. That's e 1, 3, 2. That's the sum of as even index e1 plus 2 e3 equal to 3, the same as 3 to 1. And we have 1, 2, 3, 4, 5, 6 distinct permutations of nums. Okay, so what the limit? Let's see the limitation. The constraints is 80. So this is the hard problem, and the limit is not too large and it's not too small enough to use backtracking approach, so we can think about dynamic program. Okay. And the important thing is to construct a solution that to count the number of distinct way to put digits into even or odd in this, so that the sum is equal. Um, Firstly, we need to determine if the given string is able to form a solution. For example, the third example is 1, 2, 3, 4, 5, 6 is not, it have none of the permutation, because we can see that the sum of this string is 15, and 15 is not divided by 2, so we cannot find a way to we cannot find a way to promise another string that have the sum of index equal to sum of the odds index, because if we have two sum that equal, so it's the total sum should be 2, the multiple of 2, so that must be divided by 2. So first we need to check if the total sum is, we call it as t. T is the total sum, is total. Okay. And if t is not divided by 0, then there's no solution. No solution. So just return by 0. And in the other case, that it is divided by 0, then we need, only this case we need to calculate the number of ways. So all we need is to for example, we have this array 2, 2, 2, 3, 2, just example, and we need to find a way to put into odd or even. In here we consider it is equally, so I would like to assume that we need to find the way to put digit into even position, right? This is the even position, and the sum we need to create is total divided 2, right? But yes, in on if odd sum of odd in this, and also equal to sum of even, right? So this is, we call it the target. This is the target sum, and now the problem covers we train to a sub problem, that's it, to count how many way to put in even, how many way to put in the even index that had the sum of t divided 2. We call it half sum. Yeah, half sum. Half sum. Half, sorry. Half sum. uh, and that's problem is to choose the there and we have there and divide to round off. For the case the length of num is e, odd like this. Yeah, we have two even position, 1 2 3. We have to choose this. We call it at k0. Yes, k0. We need to choose k0 element in the original num. This is num in the original num that have the sum equal to the half sum at t divided 2. Let's take an example. This one. Okay, 1 2 2 like this. 1 1 2 2. This position and this we need to select two digits in the num string, and that form the sum of this is 6. The total sum is 6 and divide 2 is equal to 0. So we have the way to choose 1 with 2, right? 1 with 2 is equal to 0. It's the way. But that we have problem that it's maybe to duplicate, right? Like we choose this and this is okay, but we can also choose this and this. But is it okay in if we consider the index as 2 unique? But if we consider the value, yes, so this is equal to this, right? So as the problem state that we don't count it. We can count the distinct permutation. All right. So now the problem is now to count how many ways of choosing and plus to k0. I say k0 digits in nums that form the sum of t divided 2, as we call it half sum, right? And after we some and we need to consider that it distinct. Okay, this so the limit is 19 digits. The num is 19 digit number. So we have almost pi to even position, right? 40 even position, and the maximum sum is we assume that on the digit is 9, and so the maximum sum is 9. This, but we only need to form the sum of t divided 2, so it's about this. It is okay. 260 360. So the limit is small enough to use dynamic program, but not as small as too small to use backtracking. Backtracking is a solution to solve this easily, but it will cause time limit. So let's see what stage to use dynamic program. You need to to um, to form the state of the function. That is to form the optimal function. What state? What is the state? What is the transition cost and and the formula? Okay. So at this we oh, this passes. What? What just happened to me? Oh no. Okay. Okay. Let's go. So I will. So the step we need to consider here now. But the problem is count how many ways of choosing k0 digits of num that form the sum of t0. It look like the 0 1 knapsack problem. Yeah, you know about the knapsack. It's one of the classic problem. One of the class problem of dynamic programming. We have n element and we need to choose k element on this that have the sum of s. Okay, so with using this called f is the optimal function. Mm, mm, uh, as okay, I forget. Because we need to consider this thing, so I would like to do it on the frequency, the frequently array. That is, if we have n m element and we have h, that's it. The digit is have count it has counted digits in the original array num. So if we choose g three digits h and put into our solution, then we have say c m tray way to choose tray element in and put it to m even position, right? And and if we choose trace h element in the total count h, then we have remaining count h minus 3 remaining element to put in the odd position. So the way I put it is c and singularity h, I call h and minus 3, and what is the number of position of even position here? That is the m and let's call the m is the number of even position, right? And n is the total position to now. Yeah, so it's the n minus m there. Okay, so if we choose to trade h digits from the total of count h digit put into m even position, and that is c 3 of m, and the remaining space is the even position. Then that's the total of n minus m position of even position, and we need to put on remaining that you don't choose to put in the even and put it to the odd position, and that's total is this choose this out of m minus m position. So it's the way. So totally we have 3 from we can choose 3 from 0 to count h, right? Then the number of way is another yes, the sum of on the way. It is the basic combination knowledge. we sum on the way. Okay, and why we multiply it, because in one way two we multiply it to C and T H. Okay. Okay. This is the formula to form the way of choosing three digits and put it n position. And now what en, yeah. So because uh, this is in order, yeah, an order permutation. Yeah, if we order, we don't care about the like is another way as 1 1. If the position is different, but in this problem is 1 1 equal to 1 1, don't care about whatever the position, the original position of them. So I would like to the dynamic programming that only care about the digits from 0 to 9. Because firstly we need to count, yeah, we need to count on these digits of the original num, and then we create a optimal function that's at age a, that we consider the number of 0 to a, the digit, yeah, the maximum is 9. Okay, the digit, that 8 is the digit. We iterate from 0 to 8 digit, and now we have the sum of even even positions in edge, and we have put three element. Can we use at not don't use three, I use k. We put we have to we already place k element, k k k element into even position. That's it, we have k, that's it, we have k even position. mm. So okay, let me write it. What, why it is red, but free. What, oh, forget it. So is the number the way to create the sum of edge with k-even position. Why is so why is so what's can't believe black free, this black 2 please. Yeah, sum of with k-even position, and we using to 1 digit. Yeah, that's a 1 2 3 2 digit. Okay, so now we let's create the formula. Let file. Okay, how to delete this? Okay, new page please. Okay, as we said before, H A S and K. What state will what state will form this state in the previous state? That's the F. As we say, we have this formula to calculate the on the combination that choose three to the H digit. We call it the E of C, and now it will choose Z out of K element, because now we have K at the state E. K is the number of even position, that we choose Z out of K position, K even position, and the remaining space is choosing C count E minus 3. and we choose k1 in the total k1. And what is k1 here? K1 is the number of odd position. That's the because we now we consider the e element. So now we iterate from 0 to e. So we now have this this now this is the total position we have till we set the we consider the each digit, and we minus it with k as the total minus the even position. Now we have k1 position of odd. That's the k1. Refer to this. And what is the previous state? That's the we come from the state that we have the state that from e minus 1 e digit, and now we add the e digit e into, yeah. So this is the way we add the e digit into the previous solution. So we multiply because e is a new element we put to it, so we multiply to the previous solution. And the previous sum is like the knapsack problem. So the previous sum is what? We choose j element, so it is j, and j element of digit e, that's the a, right? A, I, e, I don't know, I is maybe I, and what is the previous k? As before we choose j element into j element e. Previously we have k minus j element, right? So this is the finally formula of this programming, dynamic programming. Yeah. In conclusion, we have a state of we form the sum of edge using k even position, and we only use the digit from 1 to I. Yeah, then to form the I, we using approach like knapsack 0-1 knapsack problem. That's the this is the way of to from 0 to e minus, because previously we don't have the digit e, and now we put it to, and as previously we have the s j e, the sum test. Because previously we have this sum, then we put 3 element e into, so it become s, right? And previously we have k minus 3 element, and now we choose 3 more 3 element into the and put it to even position. That's why now we have 3 k element. Yeah, as this is the current state. This called is the current state, and we calculate the current state using previous state. This is the previous state. And number of way is to and this is the number of way of choosing. Yeah, as can I explained before, this is the way of choosing a j element and put it into k and predefine k position. Okay, now we calculate the time complexity as the dynamic programming problem. Time complexity is the number of states plus multiple the transition cost. The state is from 1 to 9, so it have 10, and as the sum is we need to calculate the half sum, so it is total sum divide 2, and k is maximum and divide 2, and the total number total digits in the original num string. So it's about the t is the sum is I think maximum 8 digits, maximum is 9 divide 2, and the maximum 80 divide 2, and you can see that we follow to on possible case of each e element. That's the total total of this en. So this is our our complexity is about this okay is with with the maximum constraint we can solve this problem easily within lower than 1 second, less than 1 second. Okay, now we continue the coding process. Uh, as first we need to create this to calculate this using Pascal triangle using Dynamic program to use to define it. First define oh, this is the hard problem. This is a hard problem, so it's quite hard for me to explain it clearly because my English now is not as good as the other one. So, so just record it and later I can check if I can explain this problem better. We define some extra space. dp we need to calculate the C, the combination. And then we have the db state is n, the sum is my n, 10, 9 divided by 2, okay, and the maximum position is this. Now we have to calculate the combination n, maximum n, for as we have C0 of anything is equal to 1. And we use the formula of Pascal triangle. There. If you in the case you don't know, triangle. Yeah, it's the way to calculate the C combination. Yeah, it is Pascal triangle is equal to the combination, and you can research about it. And in Pascal triangle is an element equal to the top bottom sum, the sum of two top bottom. This like 3 equal to 2 plus 1 is 6 equal to 3 plus 3. So that's why it's a 3 plus. Okay. Don't forget to modulo. Okay. And I would like to write the add mode to simplify my code in the future. That because any problem that require the mode operator, I would like to use this to pass instead of using the mode operator, because the subtract is better than the mode. Okay. And now firstly we need to calculate the total sum. Let's use total for simplify. And we need to count on the frequencies of all element. Total this, and we will increase the occurrences of the seed character, and if the total sum is not divided by 2, then just return 0. Okay, and now we init the combination of and in the side of original num 4. Now we do damage program. Add this formula here. We fall from from 0 to 9. We for the we need to calculate the current sum and current count. current count is and current sum is this, right? While we calculate the current count to calculate the K1. Yeah, K1 is the number of even position at, until we iterate to the each digit. Yeah. Now we for the this state for state edge as from 0 to as we know that as a target, our target is to either t divided by the total divided by 0, but sum when we iterate to the each digits equals sum, so we need to make a mean here to because the value large, the sum that larger than sum is not visible. We can create that sum using the first e element, right? Because this is the maximum sum can be formed. Yes. Okay, and now we for the K0, and the K of us is target to n divided by 2 is, so we need n divided by 2, but it must be less than current count, right? We can create more than current count now. Okay. And we can calculate the K1 by using count minus this. Okay. Now we need to for J to choose the number. We need to J is a number of digit E. We need to choose, so it's range from 0 to count A. Yeah. So now we have we need to calculate this formula CKZ KG. To prevent overflow, we should multiple to one long of this is K1 E K1 and and to all remaining E digit. That is this, and we multiple to F A minus 1 the count sum because we choose J digit E, so the sum we add to previous state J multiple E. Yeah. And the previous we have, because we choose J element and to put into even position, so previous state E have K minus J position, and we know we must only fall to when A count E. So this must be mean of K, because we already have maximum K even position, so we can place more than K. And G multi E not over the sum. Yeah. First, because we can create that sum, and secondly we can overflow this, right? We can overflow this because if this is larger than S, so it should be overflow. Out of index, and we all know that we can create the sum that's greater than current sum, right? And add to the current state G as rest. We in my code now, you know that on dynamic programming have an initial state, but I don't have here. So just make an if E equal to 0, we both know that we all know that with the digit 0 we only create zero sum, right? So if equal to 0, I would like to add e0. We only create the only viable way to reach the zero z s e dash g equal to, I'm sorry, not g at it at g at k, sorry, s with k, that's s equal to g minus e and k equal to g. Yes, because from we only come from the zero state to from previous zero to 0 and s and k. Now return the as we target to sorry, and minus 1. We target to the answer is to we iterate on 9 digit, and we have the sum of total divided by 2 using a half even position. Our range cow e, yeah, not J. It's my mistake. Let's see if it is correct. Okay, accepting, but it's not fast. I think we have another solution that faster, but it's enough for this hard problem. Yes, goodbye.